Okay, so we are going to do so that our girls know 7F, page 205. You betcha. I am. Okay, so number 10 says that f of x equals square root of x times cubed root of x plus the fourth root of x. Okay? So we can't do anything with radicals. We have to have exponents. So we have to convert each radical into a rational exponent. Now, we're still working with our function, so we leave that f of x. And x, square root of x becomes x to the 1/2, right? Cubed root, x to the fourth root, x to the. Okay. So now I have to distribute, right? So I'm going to distribute. I haven't taken the derivative yet. Don't try to take the derivative. I haven't even gotten to the point of where I can take the derivative. So this is going to be x to the 1/2 times x to the 1/3 plus x to the 1/2 times x to the 1/3. All right, so let's review some properties of exponents, okay? That's what I noticed. Okay? So, if we have x squared times x to the 5th, what does that equal? X to the? No! There are 2 of these. Now there are 5 of these. How many total are there? 7. Okay? When we multiply powers with the same base, we add the exponents. Okay? So in this case, this means this should be x to the 1/2 plus 1/3, right? Add the exponents. That's the rule. You're killing me with those calculators, girls. Come on. We can do this. We can do it without a calculator, right? Okay. Common denominator would be 6. So we still haven't taken the derivative yet. We're just writing that function over and over and over until we can take the derivative. So the 2/4 plus 1/4. So 3/6 plus 2/6, x to the 5/6 plus x to the 3/4. Woo! Now we have some exponents we can use. Now comes the easy part. Okay? I take my exponent, multiply it by my coefficient, which happens to be 1. I have 5/6. If I take away 6/6, right, I have negative 1/6. Next term, 3/4 times 1 gives me 3/4. If I have 3/4 and I take away 4/4, I have negative 1/4. So now I just need to simplify. 5 stays in my numerator, 6 stays in my denominator, and x comes down and the exponent changes to positive. 3 remains in my numerator, 4 remains in my denominator, x joins it, and the exponent becomes positive. All right, so number 8. So 8 was f of x equals 3 over the quantity 4x squared so, whoops, yeah. Okay. So, first, Kenzie, we have to distribute the power. So that becomes 3 times 4 squared, over 4 squared times x squared, so 3 over 16. I had to move it before. Okay? So now that x needs to come out of the denominator, right? We can take the derivative if we don't have an x up there to take. No, you can't. We learned a rule, and x needs to move up here. And if it's positive in the denominator, when it comes out of the denominator, it now becomes negative, okay? And we don't put it in the denominator because we need a coefficient out front. We want to have that coefficient out front. Because we need something to multiply that exponent by. So now we're ready to take the derivative. So you'll notice how I'm doing this, girls. I just say equal, equal, and then here's the point where we take the derivative, okay? So exponent times coefficient, negative 2 times 3 over 16 gives us negative 6 over 16, x to the negative 3. We subtracted 1. So now I have to make it positive, so it comes back down and joins the 16 down there. And it becomes positive. And I can simplify this, dividing both by 2. That's our answer.
When do you know?
All right. So we now have something called the normal line. I think I could come up with a better name than that. Okay. The normal line at a point on a curve is the line that is perpendicular to the tangent line. Okay? So look at our curve, it's in red, right? And the green line is tangent at that particular point. It's tangent at this particular point. And then if we draw a line through that point that is perpendicular to the tangent, that's called the normal line. Okay? So that point has a tangent going through it, has a line that is tangent to it, and then there is another line that is perpendicular. Okay? So if you know the slope if you recall, if we have a line that has a slope of 1/2, the perpendicular line will obviously have to have a negative slope, right? They both can't be positive, otherwise, well, they wouldn't, in fact, they could. Okay? So, obviously, the line that's perpendicular to it is going to be negative. So one has to be positive and one has to be negative, otherwise it's not going to be positive, right? Or they could be horizontal and vertical. Okay, so if we're finding the derivative, we're finding the slope of the tangent line, that means the opposite reciprocal of that must be the slope of the normal line. Okay, so we're going to take these slowly. So it says write an equation for each line. The tangent line to the curve, f of x equals x squared plus 1, at the point 1, 2. Okay? So, here's what we do. Let's take our function. A, we have f of x equals x squared plus 1. So let's take the derivative of this. Okay? We take the derivative of this function. Where is it? 2x, right? All right. Now, we are at the point 1, 2. Agreed? On the curve, we're at the point 1, 2. So we want to find the slope of the line that's tangent to the curve at 1, 2. We have an equation now to find that slope. So what we're going to do is we are going to take the derivative. We're going to take the derivative when x is what? 1. Isn't that the x at our point? We're at the point, right? So when we plug in 1 into our derivative, we get equals 2. And the derivative equals the slope of the tangent line. So what is the slope of the tangent line when x is 1? 2. Okay? I'm going to write it like this. The slope of the tangent line is 2. Voila. Okay. When we're at 1, okay, right there. When we're at 4, oh look, steeper slope, right? So once we find that the derivative is 2x,
Either y1 and x1 that we know. What is it if we want that?
no, because we were given the point at this point.
Okay, so it always goes in y1 and x.
Yes,
Not just plain y and not plain x.
correct.
Okay,
Plain y and plain x are the ones that stay in the equation,
okay.
right? The sub 1s are the point you're given. That's
Okay.
why it says sub 1. So we have a slope of 2 and we have a point at 1, 2. So we have the 3 things to put in.
Got it. Okay.
All right, this is so much time. All right. All right, so let's do B. Okay, so B has a different curve, a different function. So, okay, so B, the function is f of x is equal to 2 times the square root of x. So find the derivative of that function. So I am going to plug in my derivative of 9 equals 1 over the square root of 9, right? So it equals 1/3. Okay. So I'm going to write the slope of the tangent line is 1/3 at 9. The point 9. Okay. Now, but they don't care about that. It says what is the equation of the normal line. So if my tangent, yikes. If my tangent line is 1/3, what is the slope of my normal line? Right. So normal equals -3. Okay? So now I just use point slope form, right? Don't I have a point and a slope? Y minus y1 is equal to -3 times x minus x sub 1. Y minus, uh-oh.
You don't have a point.
Yikes! Why that? What do I do?
Wait, you know it's
Right, here's your original function, and you were looking for f of 9, right? What's the y value when x is 9? Equals 2 times the square root of 9, so 2 times 3. So f of 9, not the derivative, f of 9 is 6. So the point here is 9, 6. We had to go find it because it didn't give us. It gave us the x value, but we can go find the y value. So we come back down, and now we have something to plug in here. What was it? 6. Equals -3 x times minus 9, right? Okay. That's the normal one. All right, so it says write the equation for the tangent and the normal lines to the curve. F of x equals x plus 27 over 2x squared when x equals 3. So we have our function. F of x is equal to x plus 27 over 2x squared. Okay? So my x is in the denominator, so I need to bring it up. So 27 over 2. 2 stays in the denominator, just the x comes out.
You don't have to restrict it because there's no...
Right, it's not in parentheses. And now that becomes a -2. We are ready to take our derivative. The derivative of x would be 1 times 1. 1. Right? -2 times x to the -2 is -2 times 27 over 2 times x to the -3. Great.
Wait, I don't get, like, if your twos cancel out, I don't get why you still have, like, I know you have to subtract 1, but then you cancel out the 2, how do you?
Because the 2's, well, I don't understand your question. So I'm going to simplify this one more time. 1 minus 27 over x to the +3. So that's my derivative. Okay. And for C, I am at the point when x is 3. So I need to find the slope when x is 3. So I am going to take the derivative at 3. Okay. My x value is 3. So that is going to be 1 minus 27 over 27, which is 1 minus 1. So the slope of my line at 3 is what? 0. What kind of line? Okay, so the tangent line is horizontal, right? So the tangent is horizontal. So the normal line, it has a slope of what? You just said it, Myra. Normal line has a slope that's undefined. What? Well, it's slope of zero. Every horizontal line is slope of zero. Okay, the slope is zero. Okay. Okay. So what's the equation of this line? Okay, so the point we were given was 3. We don't know the y value, right? So we're given the y value. We'll find the y value of this point. Yeah. This is going to be y equals 9 over 2. So the normal line is going to be a vertical line, and it's going to be what? X. It's going to an x value, girls, not a y value. Vertical lines go through the x-axis, not the y-axis, right? Vertical lines go through the x-axis. Horizontal lines go through the y-axis. 3, 9 over 2. You can do this one. Right? Y minus 9 over 2 is equal to 0 times x minus 3. This whole side becomes what? 0. So y minus 9 over 2 equals 0. So y equals 9 over 2.
So now we're solving for it. Not just leaving it at.
Well, right, because it's zeroed out. Okay? You have to write the equation in the line. You can't do it for the vertical line. What do you put in for the slope? You don't write undefined in there. You can't distribute undefined. Right? Okay, so. What's the equation of that line, girls? Y equals 2. Horizontal lines are always y equals. What's the equation of this line? Okay? If your tangent line has a slope of 0, your equation will be y equals something. This is the horizontal line. What's the equation of this line? X equals 3. Vertical lines have the equation x equals something. Okay? It doesn't have a y-intercept. It doesn't cross the y-axis, right?
So there's no point to do it.
You can't write undefined in for slope. You can't distribute undefined. Okay? So you have to remember, horizontal lines will be a y equals. Vertical lines are always an x equal. All right. Okie doke. Let's do D. All right, so D says the tangent line to this function that is parallel. Parallel to the tangent at 4, negative 21. All right? So first let's find the tangent at 4, negative 21, and then find the line that's parallel. Okay. So our function actually has a very easy derivative to take. Thankfully. So I can take the derivative right away. 3 now, find this correctly. All right, so we want to find the slope of the tangent line, right? Going through the point for -21. So I have the equation for the slope. If I want to find it, if I want to find the slope of the tangent line, then I have to find the derivative at 4, right? Yes. So the derivative at 4 equals 11. Okay? All right. Now, this is where it gets, so we know the slope of the tangent line here is what? What did we find the slope to be? 11. So if I had a line that was parallel to that, what would its slope be? 11. Agreed? Because parallel lines have the same slope. So that means I want to find another line that has a slope of 11, right? So if my curve, so this is a cubic, okay? So I have a cubic function here, okay? And at 4, my slope was 11, right? It might be 11 again over here, right? Agreed? So on the curve, you could end up with the same slope somewhere along the line. That makes sense. And we have the formula to find the slope at any point, right? Agreed? This is how I find the slope at any point. So instead of just plugging in numbers, well, what's the slope when x is 2, and what's the slope when x is 3, and what's the slope when x is 4? We know this is the equation to find the slope, right? So if I set that equation equal to the slope, then I can solve for x, right? And find out what is that other x value that also has that same slope, right? So I take that equation for the derivative, which we found to be 3x squared minus 6x minus 13, and I set it equal to 11 because there's one other x value that will have a slope of 11. So now I have a quadratic, and we solve a quadratic. What do I need on one side of the equation? 0. So I subtract 11 from both sides. You've got 3x squared minus 6x minus 24 equals 0. Okay? Now, fortunately, I have a GCF, right? What's my GCF? 3. Now, Emily's going to say, why are you factoring out the GCF this time, Mrs. Bennett? Because I'm actually solving, okay? Right? So, I'm going to factor it out because it's going to be way easier to find my two numbers if I don't have a coefficient to the front. All right. Find my two numbers. What are they? They add to they multiply to -8 and they add to -2. Olivia, what you got?
-4.
Right. -4, +2. We don't care about this 3 out here, right? Divide both sides by 3, and 0 over there. So we've got x minus 4 equals 0, or x plus 2 equals 0. So the 2 points where the slope is 11 are when the function is at x equals 4 and when x equals negative 2. Agreed? Which point were we given? When x equals 4. Right? So the parallel line must go through when x equals negative 2. Okay? So the other point is negative 2 something. We have to go find the something now. Go find it.
Are these the original things or the derivative?
Okay. This is a point on the original function. So you have to use the original function to find its output. Okay?
You can put negative 2 in for all the x's in the original.
Yes, you do. Catching on. Maybe you are, but you are. Okay, Myra. Here's our function. Somewhere on the curve is a point where x is negative 2. Right? How do I find the y value? Right, so the other point that has that slope is at negative 221, right? So now we need to find the equation of the line at negative 221, right? We know the slope is 11. We have a point. Lo and behold, point to look for. Yet again. So y minus y1 equals m minus x1. So y minus 21 is equal to 11 times x plus 2. We did it. Okay? So, homework, day 4, part 2, 7G